As we discussed in the previous video, Linux doesn't use separate drive letters for different drive partitions. All the active storage devices are part of a single file system starting at slash. To understand how this works, we need to discuss how Linux uses storage devices and partitions on those devices. I'm going to use a few computer hardware terms as we go through the video. It's fine if you don't understand what they mean. You can still get the important parts. First, let's look at the storage devices on this system. We could use a command line tool to do this, but it is easier to visualize with this GUI program. We have two storage devices. The first is the VirtualBox hard drive. If this weren't part of a virtual machine, we would see information telling us the make and model of the drive. The hard drive is identified as dev SDA. The S indicates that it is a SATA drive. Different types of devices have different types of identifiers. The A indicates it is the first drive. If we had another SATA hard drive, it would be SDB. The second device is the virtual DVD I used to install the operating system. It is using dev SR0. Note that the system identifies it as read-only. This is what we would expect since this isn't a writable DVD drive. If we look at the hard disk again, we can see that the drive is broken up into different volumes, or partitions. There are two primary partitions and three secondary partitions. Don't worry about the differences between the two. It isn't important right now. The important thing is that each one of these partitions has its own ID and is mounted at a different location in the file system. The first partition is dev SDA1. Since it is the first partition of the drive dev SDA. Note that it is mounted at boot and the partition is marked bootable. It uses the ext4 file system. This is currently the default file system for Linux. It offers journaling services that help prevent losing data if the system loses power for some reason. The second partition is dev SDA2 and is mounted at the file system root. The other partitions also have different mount points on the system. /home, /var, and /temp. To get an idea of where these partitions are mounted, let's look at a view of directories similar to the one you would see in a graphical file manager. Since there are quite a few subdirectories off of the root of the file system, I have chosen to only display a few. The subdirectories that serve as mount points for the different partitions are highlighted in different colors. The partition dev SDA2 is mounted at the file system root and is denoted by the color black. The partition dev SDA1 is mounted at the boot subdirectory and is in blue. The partition dev SDA5 is mounted at the home subdirectory and is in red. The partition dev SDA7 is mounted at the temp subdirectory and is in green. Lastly, the partition dev SDA6 is mounted at the var subdirectory and is in orange. Notice that the bin and etc directories are in black as they reside on the dev SDA2 partition. Every file or directory that isn't in one of the subdirectory mount points resides on this partition since it is at the file system root. Also, there is nothing preventing us from adding a new partition, either from a new hard drive or a temporary flash drive, and mounting it in a subdirectory of /home. There are many good reasons for keeping directories on separate drive partitions. For example, if a runaway process starts filling up the /temp directory, keeping it on a separate partition contains the problem and would allow the system to continue to function. Most of the time, however, if you are using it on your personal machine or in a virtual machine, you can get by with keeping it all on the same partition. It is important to remember that despite the fact these directories are on different partitions, they all are a part of a single file system. When we navigate these directories at the command line or using a graphical file manager, we see only one file system. We can access information that lets us know there are different partitions mounted on the file system, but we don't need to know that to use the system. The configuration for how the different hard drive partitions are mounted can be found in etc fstab. Each partition has a unique identifier that the system uses to know which partition is which. If the partitions were on different drives, the normal identifiers, such as dev SDA1, might change if the drive cabling were to be changed. Let's explore some command line tools that let us look at the partitions and how they're used. The mount command can be used to mount partitions at different mount points on the file system. However, if you don't pass any command line arguments, it shows the currently mounted devices. As you can see, there are quite a few mounted devices on the system. Most of them are temporary file systems used by the operating system to function. We saw a few of these in the last video, like the proc directory. It's used by the operating system to store information about all the running processes. The hard drive and DVD are shown near the bottom. The mount command uses the etc fstab file to help make managing mount points easier. The man page for mount is a good resource if you need to manage the mount points from the command line. The df command displays the disk file system space usage of all the mounted partitions. I use the -h option to make the output more human readable and display the size using units such as megabytes and gigabytes. We can see the size of each mounted file system, how much storage space is used, and the amount of space available for use. Notice that since the DVD is read-only, there isn't any available space on the partition. Another command that can be useful is the du command. It displays the disk usage of files or directories on the disk. I frequently use it to see how much disk space a given directory uses. Let's use it to see how big the home directory is. The -s option tells du to summarize the total disk usage of the directory instead of listing the usage of each file and subdirectory. The -h option outputs the format to use human readable units. As we can see, Bob's home directory currently uses 64 megabytes of storage. There are other tools we could use to look at partitions and disks, but they are primarily used for administrative tasks and, therefore, beyond the scope of this course. Being comfortable with these tools should be sufficient for getting started in Linux.